Hello grade 12s, welcome to the second lesson on differentiation. So this second lesson on differentiation, also very important. Again, I can't stress enough how important this entire section is. This one is called first principles differentiation. You'll see later on we don't just refer to it as first principles differentiation, we also refer to it as finding the derivative using the definition of differentiation. So yes, sometimes they go first principles differentiation and sometimes they say use the definition to find the first derivative. Now, we have to first refer back to the previous video. So if you haven't seen the previous video, you need to go and watch that one first. That was the introduction to differential calculus, where we discussed the whole idea of gradients, average gradients, and we also had a little introduction to limits. And especially that introduction to limits is going to be important for this video, because if you didn't understand that introduction to limits, you might struggle a little bit with this first principles differentiation. So very important to first go and watch the video that deals with those concepts. Now, the first thing we need to talk about here is instantaneous gradient. Now, instantaneous gradient is not the same thing as average gradient, but instantaneous gradient is based on average gradient. So in the previous video, we spoke about average gradient, and we actually deduced this formula for average gradient, where we said, if I have a function f, which gives me a curve, and I select 2 points on that particular curve, and I say the first point has the point x right there, so the y-coordinate is then f of x. So we don't use that notation of y, we use the notation of f of x. So saying if I substitute x into this function, I will then get f of x, which is my y-coordinate. Now, if I then move from this point, I move a horizontal distance. So I move a horizontal distance of h units. Then obviously it's x moving a horizontal distance of h units till I get to the point x plus h. But then if I want to get the y-coordinate again, it's got to be a substitution into the function of f, so that's got to be the f of x plus h. And then we said that if it's y2 minus y1, then it's the f of x plus h minus the f of x over x2 minus x1. And in the previous video, we saw that if I go x plus h minus x, I end up with h. And we said this is very much that general formula for average gradient. Now, to talk about instantaneous gradient, we first need to go and discuss what does it mean to talk about the instantaneous gradient. So, if I take almost this exact same curve, and I now go and I say, instead of having 2 points that I draw the line through, I now only want to draw a tangent, and this, by the way, this line very importantly is from now on going to be called a tangent. A tangent is a line that only touches a curve on one single point. So it doesn't cut through 2 points like this line, it touches the curve only at that one point. So this is what we refer to as a tangent. Now I'm going to use GeoGebra here, so hopefully this will work. So if you look at GeoGebra, whoops, that was not technical difficulties. So if you look at GeoGebra, we have the same situation there, where we have a line that goes through 2 points. And then obviously there's a horizontal distance between these 2 points. Then you should be able to see that if I go and I drag this point closer and closer and closer and closer and closer, then what's going to happen is eventually those 2 points will then become 1 point. And when those 2 points become 1 point, I don't have an average gradient anymore, because it's no longer a line that goes through 2 points, it's now a line that just goes through that one single point. That right there is referred to as a tangent, and the gradient of that line is referred to as my instantaneous gradient at that point. So not the average gradient between 2 points, the instantaneous gradient at that particular point. So let's see how we're going to get that instantaneous gradient. Now, the first thing you need to realize is the only way to make that point move closer and closer and closer and closer and closer to that point to eventually get a single point is to make the distance h between the 2 points as small as humanly possible. And ideally, I would want that distance h to be equal to 0. But if you look at the formula that we deduced, you'll notice h cannot be equal to 0. Because if h is equal to 0, I'm going to be trying to divide by 0. So no, h can't be equal to 0. You need to understand that very clearly. But if I go and I look at the whole idea of limits that I discussed in the previous video, we said with a limit, even though I have a 0 denominator, I could actually still calculate the limit. So I can go and I can say, instead of saying h is equal to 0, I can say it's the limit of h tending towards 0 of that average gradient formula. So again, I'm not setting h equal to 0. I'm saying h goes closer and closer and closer and closer to 0. Because like I said, I agree I cannot divide by 0. But if I make this little distance between the 2 points as tiny as possible, so if I make it 0,000000001, it's not equal to 0, so I can still divide by it, but the distance between the 2 points is so small, it tends towards 0. That means I actually get an accurate gradient, and that means I get an instantaneous gradient. So not the gradient, the average gradient between 2 points, I get the instantaneous gradient at a single point. And that is now going to become the definition for our first derivative. So welcome to your first differentiation, f accent of x, or also called the first derivative. And we are now going to say, by the definition of the first derivative is the limit of h tending towards 0 of the f of x plus h minus the f of x of h. So that right there is my definition of my first derivative. So that's the notation for first derivative. We are going to do a video later on that is going to discuss all of these notations, talking about what are the notations when you write derivatives. But that for now is the formula for first derivatives. So let's take a closer look at that formula of first derivatives. Okay, so we call this first principles differentiation. On your information sheet, this formula is given, where again it says f accent of x, also called the first derivative of f. In other words, remember from the previous video, I say derivative, you say gradients. So please remember the first derivative is the gradient of the function of f, but we'll get to that also later in great detail. Then we're saying it's the limit of h tending towards 0, so that reads it's the limit of that particular function right there, the average gradient in this case, where h tends towards 0. And that formula, as I specified, is the average gradient of f from the previous video. So where I take the average gradient, but I make the distance between the 2 points as small as possible, so I make it tend towards 0. I don't get an average gradient between 2 points, I effectively get an instantaneous gradient. So let's do an example of how this works. This example is example 1 on page 198. It says, use the definition of the derivative to find the derivative of fx equal to a half x squared. So we are now going to employ this formula. But when we employ this formula, you need to go and you need to realize I need a very important substitution, which is the f of x plus h. By the way, the f of x will always be given to you. So in each and every single problem, the f of x will be defined differently. So in this particular problem, f of x was defined as a half x squared. But I need to use this formula. I now need to calculate the f of x plus h. So that's generally what I do first. And yes, we will get to the Luzande method in the next example. I will write it down step by step by step. So again, shout out to Luzande. We will do the Luzande method. So first things first, I'm going to go and calculate the f of x plus h because I need that to substitute it into the formula. And for that, I'm going to just go, it's a half of x, but now it's no longer x, now it's x plus h. So it's the x plus h squared. So I'll leave the half on the outside for now, and I will go and calculate x plus h squared. So that's x squared plus 2xh plus h squared. And I will distribute that half, saying it's a half x squared plus, and now half times 2 is 1, so it's plus xh plus a half h squared. So now I've got everything that I need to substitute into this formula, which is the formula for first principles differentiation. So I'm not going to write down the formula because in the IEB, they don't require you to first write down the formula. You can immediately substitute into the formula. So I'm immediately going to go and substitute into that formula. So according to the formula, it says the derivative or first derivative of fx is equal to the limit of h tending towards 0 of f of x plus h, which is this one that I've just calculated and simplified. So it's half x squared plus xh plus a half h squared minus, and now this people is going to become really important, not for this one, but later. I always have a habit of putting that in brackets because very often fx is a polynomial, meaning it's not only one term, it might be 2 or even 3 terms. You'll see in the homework I'm going to give you one that's got 3 terms. So because you are subtracting a polynomial, put a bracket around it so that you remember I'm not just subtracting the first term, I'm subtracting all of the terms in the bracket. So it's just a very good habit to have. So I'm going to go minus a half x squared. There we go. Now, this is something that will always happen. So please, if you made a mistake calculating that f of x plus h, then there's going to be a mistake over here. And you can spot that mistake very easily because of the following. The only way I can work out this limit is if there is a common factor h at the top to divide into the h at the bottom. Because like I said in the previous video, in its very nature, limits is just a substitution. So I want to substitute h with 0, but I cannot substitute h with 0 unless I can find a common factor h in the numerator to divide into the denominator at the bottom. So let's see if that works out. So I've got the limit of h tending towards 0 of, and now look what happens here. Half x squared minus half x squared, that eliminates, it's gone. That xh comes down plus half h squared over h. And you will notice that always, if you calculated the f of x plus h correctly and you did this subtraction correctly, you will always, in the numerator, have a common factor of h that you can take out and then you can divide into that h at the bottom. So we're going to go and say it's the limit of h tending towards 0. I'll take out the common factor of h, and then I've left x plus a half h over h. And perfect, that h divides into the h, and because I no longer have that h in the denominator, I can now do the substitution, which, like I said in the previous video, that is what a limit is. It's pretty much a substitution. So when I do the substitution, all that happens is that limit of h tending towards 0 falls away, and it becomes x plus a half times 0. Now careful people, we are not substituting x with 0, we're substituting h with 0. So if you go and you look at it and you go like, why didn't you substitute? It's because I'm not substituting x with 0, I'm substituting h with 0. So eventually what I have left is x. And that, people, is the first derivative of that particular function. So if fx is equal to a half x squared, then the first derivative of fx, the gradient function, and I'm going to refer to that again and again so you guys can remember that's what the first derivative is. It's called the gradient function of f. So the gradient function of f is then equal to x. And that's pretty much what we're going to do. Now in the next example, I will go and I'll write it down step by step because this is a very easy procedural sum, and the good news is they always in the final exam paper, they always ask one like this. So you will never ever get an exam where they don't ask it. They did ask it a little bit strangely in the 2018 paper, but I will do that one as an example as well, just so you can see, according to the Joshua method, okay, that's easy, now what can they do with this? So I will discuss one of those examples. Okay. So the first past paper example we're going to look at comes from the November 2016 paper 1, and that's from the IEB. That just stands for National Senior Certificate Examination. So in question 6a, they said, given that fx is equal to 3x squared plus 2x, determine the first derivative, or f accent of x, from first principles. Now, this right there, people, that is key. The moment they tell you you have to do it from first principles, They have specified the method. And because they've specified the method, you're not allowed to use any other methods except this first principles method. So if you decide, no, I'm going to rather use the differentiation rules, which I will teach you later on in one of the later videos. If I decide I'm going to use the differentiation rules, they do not give you your marks. So if they specify you've got to use first principles, you have no choice in the matter. You have to use first principles, please. So first things first, I'm going to use the formula, but in order to use the formula, I need that f of x plus h. So that, people, is always step one. Step one, determine the f of x plus h. And that, people, is just a simple substitution where whenever I've got this x in my original function there, and there, and there, I'm now, instead of writing just x over there, I'm going to substitute x plus h in there, and in there, and in there. So that means f of x plus h, in this case, is equal to 3 times x plus h squared plus 2 times x plus h. And I have to simplify it, because if I don't simplify it, I'm going to have to simplify it in the formula, which makes it quite tricky. So we're going to say it's 3 times x squared plus 2xh plus h squared plus 2x plus 2h. And then I distribute that 3, saying it's 3x squared plus 6xh plus 3h squared. And then plus 2x plus 2h. So now that I've determined f of x plus h, I'm going to come to step 2. And step 2 is I'm going to substitute f of x and f of x plus h into the formula. So step 2 is substitute f of x plus h and f of x into the formula. And like I specified before, this formula is on your formula sheet. You don't have to know this off by heart. But obviously, you still need to recognize it. So you need to recognize the formula for first principles differentiation. So the formula says the first derivative of fx is equal to the limit of h tending towards 0. And now, over here, we have to substitute the f of x plus h. And that's why I calculated it over here. So I can just go and I can substitute it into the formula. So I say it's 3x squared plus 6xh plus 3h squared plus 2x plus 2h. And I look to be running out of space here, so I hope I can fit it in. Minus, and now please remember, people, that's where I spoke about the bracket. In this case, the bracket is crucial, because fx was defined as a binomial. So I'm not just subtracting a single term, I'm subtracting both of those terms. And if you don't do the brackets, you're going to get this step wrong. So f of x is equal to 3x squared plus 2x. Yay, just managed to fit it in with a little bit of help. Yes, I did. So there's over h. Now, there's a lovely little check here. Lovely little check, and I'll put that on the side note over here. Check that every single term that does not have h as a factor. And when I say it doesn't have h as a factor, this term over here has got h as a factor. This term over there has got h as a factor. This one and this one doesn't have h as a factor. So you want to have this check to make sure that every single term that doesn't have h as a factor will eliminate. Because the next goal is always going to be to take out h as a common factor. So I'm going to simplify this. And you'll spot 3x squared minus 3x squared is 0, so that eliminates. 6xh, you've got it over there, plus 3h squared. And then there again, 2x minus 2x squared. And that's where that distribution becomes important. The bracket becomes important, because if you didn't put the bracket, you would have thought the 2x remains, but it doesn't. It's 2x minus 2x, which eliminates. And then that plus 2h comes down. So over h. So please remember that little check. Check, very importantly, all terms without an h must eliminate. So that is a very important check, or otherwise you know you did something wrong. And it's either going to be because you didn't put a bracket around that, so you didn't distribute, or it could possibly be because you calculated that incorrectly. But that very important, terms without h must eliminate, because step 3 is then going to be factorize the numerator and you will always factorize the numerator by taking out a highest common factor of h. And if there's not a highest common factor of h, again, you did something wrong. So we're going to then say that means the first derivative of fx is equal to the limit of h tending towards 0. Now we factorize h, leaving us with 6x plus 3h plus 2 over h. And then I can go and I can divide h away. So that's going to be step 4. Divide h, and now you can do the substitution of h with 0. Now, when I say sub h with 0, it's obviously all the h's that are left after you've divided by h. Because what's going to happen over here is you're going to say h divides into h, but there's still an h left. So when I said sub h with 0, I'm specifically referring to that little h over there. So now, because I'm doing the substitution, please remember, according to the rules of limits, I can now drop that limit because I'm doing the substitution. You'll note that all the while I was using the formula, the limit stayed while I was simplifying it. The limit stayed while I was simplifying it. I only went and dropped that h, after I dropped the h, and I could do the substitution, did I drop that limit of h tending towards 0. So now I can go and I can say 6x plus 3 times 0 plus 2, and that means eventually we've got an answer of 6x plus 2. And that, people, is my first derivative of that function, 3x squared plus 2x, by using first principles, step by step by step, using the Luzande method. So that's pretty easy and straightforward. Now, the next past paper exam problem we're going to do was in the November 2017 paper. Again, it was the IB paper. So in that November 2017 paper, question 5a, they gave us the function fx is equal to x minus 3 squared. And the first part is they asked to determine the first derivative from first principles. So again, people, from first principles. If they require first principles and you do not use first principles, it's wrong. So they've specified the method, you've got to go and you've got to use that method. So, according to the steps, I will first have to calculate the f of x plus h. And I will sub it in there. So again, I'm just going to highlight that so you can see. There's x, there's x. So that means wherever x was, I now have to go and substitute x plus h. So yes, I agree, this is going to be quite annoying to do. But you can always just go and you can say it's x plus h minus 3 times x plus h minus 3, which will unfortunately result in 3 terms multiplied by 3 terms. So that's going to give me 9 products. So I'm going to have to multiply the x, by h, and by negative 3. And then I'm going to have to multiply the h by all 3 of those terms. And then I'm also going to have to multiply negative 3 by all 3 of those terms. So let's see how this goes. I need a little bit more space here. So I've got x squared there, plus x times h, which is xh, plus x times, or in this case, x times negative 3, so that's going to be negative 3x. So that's the first 3 products. Now here come the next 3 products. So that's h times x, so xh, plus h squared, minus 3h. And then the last 3 products is minus 3 times x, so it's minus 3x, and then minus 3 times h, so minus 3h, and then finally minus 3 times minus 3, which is plus 9. So simplifying that, seeing if there are any like terms, I'm going to bring down the x squared over there, and then I've got xh plus xh, which is plus 2xh, I've got minus 3x, which is minus 6x. And then I've got h squared, so that's plus h squared. And I've got minus 3h, which is minus 6h. And then I've got that little plus 9 over there. So tough, but not undoable. Now I'm going to substitute it into the formula, saying the first derivative of f is equal to the limit of h tending towards 0 of all of that, which is the f of x plus h, minus that. Now, this one, before I substitute it into that one, it might actually be easier to expand this as well, so that I don't have to expand it first in this formula. So you could go and just quickly over here say this is x squared minus 6x plus 9, just so it's easier to substitute into the formula. Again, please remember that bracket, people, otherwise you're going to have a problem in the next step. So there we go, over h. So in the next step, we will always have that result where any term that does not have h as a common factor will eliminate. So let's check if this is correct. I've got x squared over there minus x squared over there, so that eliminates. 2xh, that's got a common factor of h. And by the way, you can actually shorten this by immediately taking out the common factor of h. So you can take out the common factor of h and you can say 2x over there. Then I've got minus 6x, which doesn't have that common factor of h, but I've got minus 6x plus 6x, which means it eliminates. Then over there I've got h squared, which I can bring down, but I've already taken out the common factor of h, so that's going to be h over there. I've got the minus 6h, which is then going to be minus 6 over there, because again I've taken out the common factor of h. There again I've got 9. 9 does not have that common factor of h, but 9 minus 9 eliminates. And then I can divide away these h's, and in the next step, I can simply go and substitute h with 0. So if I substitute h with 0 over there, I'm just going to write down the result. It's going to be 2x minus 6. And again, look at your notation. I've dropped the limit because I've done the substitution. I've substituted h with 0, and that then is the first derivative of this particular function that they asked me. Right, now there's a follow-up question here. There's number 2. And the number 2 says, sorry, that's another example. Determine the gradient of f where x is equal to negative 3. Now remember, people, I said this. I say gradients, you say derivatives. So if I want to calculate the gradient, I need to use the derivative. And I just calculated the derivative saying the first derivative of fx, or the gradient function, is 2x minus 6. But they want to know the derivative where x is equal to negative 3, which simply involves a substitution. So if I go and I say the first derivative where x is equal to negative 3 is then equal to 2 times negative 3 minus 6, which is then equal to negative 6 minus 6, which is equal to negative 12. So that answers the question, determine the gradient of f where x is equal to negative 3, and the gradient of f where x is equal to negative 3 is negative 12. Okay, so I was going to add the last little example into this video, but I'm running a little bit short of time, so I will just do an additional video, and I will call that additional video extension example. So that extension example is this example. You'll see it in the next video, which is from the November 2018 paper, and that's going to be part of our Josh method, which says, but how can they change this? How can they make this different? Okay, right. So I will see you in the next video.